Welcome to 4.1, page 2. Let's get started here. We've got some radian measures that we're dealing with again here. And this says determine two coterminal. Terminal just means stopping point. Two angles that stop at the same point in radian measure, one positive, one negative for each angle. So here is 26. We go 7/6 pi this way. That's 1, 2, 3, 1, 2, 3, 4, 5, 6, 7/6 pi. I could have gotten there this way by going backwards 1, 2, 3, 4, 5 pi. So that's, or not 5 pi, 5/6 pi. So 1, 2, 3, 4, 5 steps of 1/6 pi. 5/6 pi is the solution. And now we've got to get here by spinning forward. And first thought might be, well, how else could I do it? Well, we could spin around as many times as we want, and that's why it says there are many correct answers. But there are going to be a couple answers that just make more sense than the others. I don't think it makes too much sense to spin 40 times around and then go there. So let's go 7/6 pi. Here's one of the answers. I think I'll use some space up here. 7/6 pi. Let's spin to here, and let's spin around another full revolution, which would be 12/6 2 pi, or 12/6 pi, and we get 19/6 pi. That gets us there as well. We don't have to draw them, just have to come up with them. So 5/4 pi, 1, 2, 3, 4, 5. I could get there by going backwards 1, 2, 3. Oh, look at this. I should have negative 5/6. Excuse me. So negative 1, 2, 3. Negative 3/4 pi. Or I could spin to here 5/4 pi, spin 2 pi radians around, but 2 pi is 8/4 pi, so I end up with 13/4 pi. And everything pretty much like that in this section. So negative 7/8. 1, 2, 3, 4, 5, 6, 7, 8. We're right here. Well, I could go forward 8/8, and I have one more eighth to go. So 9/8 pi is a positive possibility. I need a negative solution as well. So negative, I could go, let's see, I made that awfully big. Negative, I could go negative 7/8 and negative 2 pi. Negative 7/8 pi and negative 2 pi. So that would be negative 7/8 pi and negative 16/8 pi for negative 23/8 pi. Pi on 12, I'm going to go a little smaller here. 1/12, that means it takes 6 steps to get to here. 1, 2, 3 to the middle, 4, 5, 6, but we're just right here, just 1/12 pi. A twelfth of 180, but, oh, by the way, is 15 degrees. Really small angle right here. How else could I get there? I could go backwards 12/12 to here, and another 12/12 to there, but one shy of that. 12 and 11/12. Or you could think of this as 24/12 pi to get all the way around either direction. So this would be negative 23/12 pi. Take them all off. Or I could go to 1/12 pi and then another 2 pi around to 1/12 pi and another 24/12 pi. 1/12 plus 24/12, 25/12 pi are two solutions right there. And now we go back into what should be more of a comfort zone, I think, for you. Estimate the number of degrees in the angle. So I don't think they're dealing with positives, negatives here. We just want that angle measure as though it was geometry. And if I put a right angle in here, it looks like it's roughly halfway through. I'm going to say approximately 45 degrees. Now, on these problems, on this problem on 29, there's going to be an answer key. Don't just make certain that you're relatively close. I don't expect, because this might not be 45 degrees, it might be 48 degrees. I'm not expecting this exact, but we sure ought to know when we draw this one in that we're over 180 degrees and not halfway through the next 90. See what I'm saying? We're 90, and then we're less than half of the way through to that next stopping point. Okay, which quadrant do we lie in? No problem. 90 and 30 more. We're somewhere in here, quadrant 2. 181 degree rotation takes me around to here and just barely peaks out into quadrant 3. 87.9. Well, that's less than 90. It's close, but it's less than 90. We're somewhere up in here in quadrant 1. Negative 8.5. Well, it takes negative 90 to get all the way to here. Negative 8.5 somewhere in here. Quadrant 4. You know, they throw these decimals on there, but it doesn't really matter. Negative 90. Whoops, wrong way. Negative 90. Negative 180. Negative 270. We're shy of negative 270, something like that. Quadrant 2. And 12.35 degrees is just a small rotation here into quadrant 1. Okay, sketch each angle in standard position. 60 degrees. Somewhere right around in there. There's our angle. 180 degrees, that's a forward rotation, halfway around. 270 degrees, that's 90, 180, 270. So we're here and here, but our rotation is this way. Negative 120, there's negative 90 and 30 more. Something like this. And on the first page that we did, I talked about this a little bit. Here we would say that there's a 60 degree reference angle. Don't have to do that for this problem, but it's where we're headed. It's the smaller angle from where an angle terminates. It's the shortest angle to get us back to the x-axis. So rather than 120 this way, it's 60. But that's just a preview of where we're going. Now, negative 450, no big deal. I'm going negative. So this would be negative 360 to get around here. That leaves me with another 90 to get to there, but we have to illustrate that this is negative 450, not negative 90. So we went spiral it around like that. 600, let's see. Start here, I rotate around. That's 360. I need another 240 degrees to get to 600. 90, 180, 270. I need most of that 270. I need another 240, so 30 degrees short, somewhere like this, but let's represent it. There's 360, and then from there we went around that 240. And that's a pretty quick page for you. Once again, a reminder from first page, we cannot afford to be pretty good at this stuff. This has to be absolute automatic for us. So check your answers absolutely, completely, thoroughly.